This video is going to look at finding common denominators for fractions and for polynomial expressions or rational expressions. There are several different ways to find common denominators. There's a quick and dirty way, and this is fast because you don't really pay attention to what you're finding a common denominator for. You basically multiply by everything in sight. So you put all the possible pieces together, and that gives you a common denominator. So it's quick. You don't have to do any analysis of the fractions or the polynomials or the rational expressions that you're working with. But you might end up with something that's more complicated or requires more simplification than you would if you were doing something a little bit more elegant. The other thing you can do is to find the least common denominator. And here you take a look at the factorizations of the different denominators that you're working with, and you only multiply or include the things that are missing from one or more of the fractions that you're trying to put together. So let me show you an example, and I'll show you how each method varies. So quick and dirty method. Let's start with just some simple fractions. Let's look at 1/2 plus 1/6. The objective when you try to find a common denominator is to make the denominators look identical. You also, when you're doing this, you want to make sure that what you're doing doesn't change the values of the expressions involved, or values in this case of these fractions involved. So I want to write this 1/2 in a different way so that its value is the same, but it has a denominator that's the same as this other fraction here, 1/6. So the quick and dirty way is to put the second denominator into the first fraction and the first denominator into the second fraction. We do that by multiplying top and bottom by the same number. This won't change the value of each of the terms, but it will give us what we need. So I take the first fraction and multiply top and bottom by 6. That's the denominator of the second fraction. And then I take the second fraction and I multiply top and bottom by 2, which is the denominator of the first fraction. So this is quick and dirty because I'm not really worried about what these things are. I just mix them together, and that gives me the same denominator in both of these terms now. Okay, so we do these transformations. If you remember how to multiply fractions, we multiply numerators and denominators in both of these terms. So we get 6 times 1 is 6, 2 times 6 is 12, and in the second case we have 2 times 1 is 2, and 2 times 6 is 12. You have to be a little bit careful. You might write in multiplication signs between these two fractions, or put a set of parentheses in if you're having difficulty with the notation, if you're getting distracted by that looking like 26 rather than 2 times 6. Right, so that's the quick and dirty way. The operation now gives us two fractions that have the same denominator, a denominator of 12. So we can now add these by adding the numerator. We get 8/12. Okay, so we get the common denominator, we add them together, we get our result. Let's look at the same example, but I'll do it by finding the least common denominator rather than this quick and dirty method. If I want to find the least common denominator, what I need to first do is kind of dissect the denominators that I'm trying to add together to see what component parts they have. So I look at the prime factorization of each of these denominators. 2 is a prime, so 1/2 is its own, 2 is its own factorization. So nothing needs to be done there. 6, however, has interesting factors. 6 can be written as 2 times 3. Okay, so we do a little bit more work in looking at the factorizations of the denominators, but now when we get a common denominator, we only introduce the things that are missing. So the first fraction has just a denominator of 2. The second fraction has a denominator of 2 times 3. The only thing I need to include to make these match up is a factor of 3 in this first fraction. So if I multiply top and bottom of the first fraction by 3, that'll give me a common denominator, and I'll be able to add these things together. Okay, so we go ahead and do that. 3 times 1 is 3, 2 times 3 is 6, and then 2 times 3 is 6 in the second fraction. So now we find the least common denominator in this case is 6. I have 3/6 and 1/6. If I add those together, I would get 4/6. And now we have two different answers, okay, from these two different methods. We have 8/12 and 4/6. These two answers are actually equal to one another, but you have to reduce the fraction to see that they're the same. So this 8/2, I can take out a common factor. I have a common factor. The numerator is 4 times 2. The denominator is 4 times 3. So this first fraction is equal to 2/3. And in the second case, I have a common factor of 2 in the numerator and the denominator. 2 times 2 is 4. 2 times 3 is 6. That reduces to 2/3. So we see that the answers that we get in both of these cases are equal, but the difficulty that we introduce with the computation moves to different places. In the quick and dirty method, we don't really have to think about what we're doing to make the common denominator. We kind of introduce anything that we see. Then that gives us a little bit more work when we're doing the reduction of this fraction. We're trying to simplify it down to its lowest terms. If we find the least common denominator, there's less algebra, there's less arithmetic in converting the fractions to having a common denominator, but we need to do a little bit more work in finding the factorizations of the things that are in the denominator. So we have to analyze them a little bit more carefully before we start adjusting them to give them that least common denominator. Okay, so that's the basic idea. The mechanics of this process don't change if we're trying to find the least common denominator for rational functions. Or rational expressions. So let's suppose I want to add two rational expressions together. So remember that a rational expression is a ratio of polynomials. It's a fraction. We can use fraction notation, but there's a polynomial in the numerator and a polynomial in the denominator. So suppose I wanted to add together 1 over x plus 1 plus 2 over x plus 3. I see two different denominators, two different things in the denominator. The easiest method with rational functions is usually going to be this quick and dirty method. Finding the least common denominator is a little bit easier in certain cases, but you have to see a factorization in the denominator. In this case, there is no factorization, so these methods are going to coincide. They're going to look exactly the same. So to find a common denominator here, I take the first fraction and I want to see this factor of x plus 3 in the denominator. I have to multiply by that. So I'll write this first fraction as x plus 1 multiplied by x plus 3. And then do the same thing in the numerator. 1 times x plus 3. Since we've multiplied numerator and denominator by the same thing, that doesn't change the value of the rational expression at all. And then the second term, I need to see this factor of x plus 1 start to appear. So I'll multiply top and bottom by that factor. And here, it really helps to use parentheses on any of these expressions to make sure that you don't mix things up or mistake one step of algebra for another. Okay, so this is the process that we're doing to get the common denominator. Once we have the common denominator, we're free to add these things together. Okay? So we have the denominator of x plus 1 multiplied by x plus 3. And in the numerator, we can do the multiplication here and then combine like terms. So 1 times x plus 3 gives us x plus 3 if we distribute that 1 across. And 2 times x plus 1 gives us 2x plus 2 if we distribute the 2 across. Now we can combine like terms. I see two separate x terms. 1x here and 2x here, add those together to give me 3x. And then I see these constant terms, a plus 3 and a plus 2. Adding those gives me plus 5. And that completes that example. I'd like to do one more example that's a little bit more complicated where we can actually draw a contrast between that quick and dirty method and the least common denominator method. For these examples, I'm using pretty simple rational expressions. I'm leaving just constants in the numerator. This is to simplify the calculations. The process, the ideas don't change at all if we have a more complicated polynomial in the numerator. So let's say that we have, let's put something a little bit more complicated. So let's put an x in the numerator and x minus 1 in the denominator. And let's add this to 1 over x squared minus 1. Okay, so this is the problem that I want to consider. I want to get a common denominator here, and I'm going to do it the quick and dirty method, and then I'll show you how to do it using the least common denominator method. All right? So quick and dirty, you're kind of adding in, or not adding, you're multiplying and dividing by the pieces of the denominator that you need to introduce. So the first piece needs to get this denominator of x squared minus 1 to appear. So we have the fraction that we start with. We multiply top and bottom by this factor, x squared minus 1. And in the second term, we need to introduce a factor of x minus 1. Okay. Once we've introduced those, that'll give us a common denominator. We can work out the multiplication in both of the numerators, and then feel free to add these things together. And let's write this down maybe over here. So our denominator looks like x minus 1 multiplied by x squared minus 1. And our numerator is going to look like, do the multiplication here, we get an x cubed minus x. And in the second term, we're going to get a plus x minus 1. Okay? So those terms are going to combine. So now we have a x cubed minus x plus x minus 1. And this gives us, if we simplify it, this looks like x cubed minus 1 divided by this denominator, x minus 1, x squared minus 1. Okay, that's fine, there's nothing wrong with that, but it turns out that that can be simplified quite a bit. So let's look at this just by finding the least common denominator of these two rational expressions. Or the least complex, really, not the smallest necessarily. Okay, so to do this using least common denominators, I just need to factor each of the denominators. I want to break it down into component parts and only multiply by what I need to make them identical, make the denominators identical. So x minus 1 doesn't really factor, it is one piece. But x squared minus 1 is a difference of two squares, so that does factor. So the second piece looks like x plus 1, x minus 1. Okay, that's the difference of two squares pattern applied to x squared minus 1. When I look at this second rational function in its factored form, I see that I already have a copy of x minus 1 in the denominator. That factor already appears. So the only thing we need to give these a common denominator is to influence or multiply top and bottom of the first rational expression by this x plus 1 term, that x plus 1 factor. So if we introduce that, we get x times x plus 1 divided by x minus 1, x plus 1. That's the factor that we're introducing. And then we're adding that to this other piece. Plus 1 times x plus 1, x minus 1. Okay. Now we add these together. They have a common denominator, so we can combine like terms, do the multiplication at the top, and go from there. Multiplying this thing out, we see we have x squared plus x. From the second term, we have a plus 1, and this is all divided by x squared minus 1. If we multiply this difference of squares out, we get that original denominator that we started with. So here's the difference. When we find this least common denominator, we get this nice rational expression, x squared plus x plus 1 divided by x squared minus 1. This is equal in value to the answer that we got from the first method, except the first method is more complicated. We have an extra factor of x minus 1 that appears in the numerator and the denominator. It's not obvious that that's there. We would need to factor this cubic x cubed minus 1, which might be a little bit difficult. But this expression can be simplified greatly. It can be turned right into this expression that we got using the second method. Right? So it's really up to you. It's a judgment call whether you want to just get the common denominator as quickly as possible, or you want to try to find the simplest denominator that both of your rational expressions can share. Okay, so that kind of completes our review of finding common denominators both for fractions and for rational expressions.